So the first step here, as far as the whole IAM functionality, the identity access management functionality, is to give the user the ability to gain access to the system, the identity and authentication part of this. Now, as I said, most organizations now have begun to develop and require some type of multi-factor authentication requirement, and they should. Individual passwords and user IDs, passwords, PIN codes, things like that. That is the first type of authentication factor, something knowledge based. But that information is so very easily stolen or tricked out of people, unfortunately. So requiring some additional steps, some additional mechanism to allow that user to further prove that they are indeed who they claim to be is a very, very good idea. You want to make certain that the design of your authentication process in general is very strict. It is not easily circumnavigated, and it is something that, although it should be strict and have very strict requirements as far as identifying the individual, it should not, however, cause a massive delay. Now, we've seen that in some cases, especially with the biometric type of authentication. We'll talk about that in more detail in a little while. But you want to make sure that it's strictly designed, very specific on what you're looking for. You don't want to be too verbose with error messages, for instance. You don't want to give away the store. If you have a panel that says key and a user ID and a password, and one or the other is incorrect, well, you don't want to tell them which. The proper error message would be one or the other of your credentials is invalid. Try again. Don't say, oh, you got an incorrect password, implying that the user ID is correct, or vice versa. So be very vague on that. And that tends to work better as far as instructing the user to exactly what it is you're expecting from them. And the system itself should be set up so that it enforces some very strict password rule concepts. You want to have a minimum length of password that's required. I personally would start with a very bare minimum of 8 to 10 characters. And the more characters you add on, the more strict and strong the password is. And along those lines, too, I think I misled you guys yesterday on the number of possibilities that a password could be. Matter of fact, I know I did because I reviewed the part of the tape last night. I was telling you with an 8-character password, that is only 99,999,999 possibilities. That ain't even close. It's actually about 30 to the 8th power when you look at it. If you're looking at a QWERTY keyboard, and that's something like 6.5 quadrillion possibilities that it could ever be in that password. Pretty strong, but a computer program can brute force and spin through that in a matter of hours, as a matter of fact. So you have to be very strong with the passcodes or passphrases. Me personally, if you start with a 10-character passphrase or password, there's a computer program will take hundreds of years to figure out what that is, working on just that problem. So that's strong, very complex. You want to enforce the complexity. Enforce things such as uppercase characters, lowercase characters, digits, special characters. And if you combine all of those together on a QWERTY keyboard, that's about 33 to 35 different combinations that an individual character could be. Uppercase, lowercase, digits, special characters, all of those combined is about 33 different variances there. So that's what you have to think about when you're creating the complexity. Now, of course, we've all seen these really good password management applications that will, they will suggest a large, complex, very strong password as well. Some people tend to want to use terms that are easier for them to understand, but you got to be very cautious with that if you're doing that. You also want to manage things and have the system manage things such as how many times am I required to change my password before I can reuse an old one? History and aging, there's what we're talking about. The NIST organization, National Institutes of Standards and Technology, has some very, very good guidance documentation that you can get from their website. And it's NIST.gov, as a matter of fact. And they've got several free publications. They call them special pubs, SPs, that you can get that have really good guidance on not just passwords, but other security concepts in general. Okay. Now, we also have, and this is built in for the most part into most of our modernized browsers, a password manager of some sort, credentials manager, as it were. If you're going to use those, make very, very sure that it is storing that information in encrypted format and that it is indeed highly secure. I use those on a couple of browsers that I use, and it's very secure, very highly encrypted, and it manages the passwords. And I'm one of those guys that I don't use the same password for multiple accounts. I just don't do it. Of course, having had your identity stolen as a result of two different corporate data breaches will lend towards you being a little bit more password security conscious. But I have the wife in the same role, and she hates it because she has to track all the passwords for all of her accounts, and she does her banking and bill paying and other things online. So, but we just don't use the same password for multiple accounts. People get caught in that and end up getting all of their accounts compromised and money stolen, online accounts, TV subscriptions, things like that. They use the same password for every one of those. And when the bad guys figure out one, boy, they got them. That's the keys to the kingdom to everything that person had. I talked about multi-factor authentication. Historically, there have been three basic types of authentication factors that we've all probably become pretty familiar with. There is the knowledge base, something you know, user ID, a password, a PIN code, a phrase of sorts. Knowledge base. Okay. The second type of factor is ownership base, something you have. We're talking about a swipe card, like you cats in the DoD. That's your cat. That's something you have. But we've also seen these key fobs, some type of physical token that also serves as a authentication factor. You present it typically to some type of reader. But that also I've seen is used for sending, for instance, a digital token. I have a couple of accounts that I've dealt with in the past. Two different universities I did training for. When I go to log into their online network sites, user ID, password, they would immediately send back a token code to my mobile phone that I then had to accept that token into like an authenticator application. Is a hashed password, a one-time, time limited too. So if I didn't accept that and validate that token within, I think, 60 seconds, it expired and we had to do the whole thing over again. So ownership, something you have. Then we start getting into biometrics, and there's a couple of different flavors in the way that most vendors actually look at the biometrics. It's something you are, your voice print analysis, your facial recognition, iris scan, retinal scan, fingerprint, palm print, those types of things. And then there's sort of another version of that. They call it something you do. In my opinion, also biometrics. And I'm talking about the way you move, gait analysis, the swipe patterns, facial gestures, things like that. And then finally, there's the geolocation. Systems give us the ability, security systems give us the ability to predefine, in essence, a geofence, a longitude, latitude, coordinates, as it were. In the old days, GPS was used primarily for doing that type of location. And of course, they use satellite triangulation. Now they're actually using 4 satellites to give it a much more accurate finding, geolocation. But it's a longitude, latitude coordinates, and I don't know if you guys remember the old days of GPS, but the ground-based GPS locators, I mean, it was a boat anchor size thing. You could use it literally as a weapon, and the accuracy on those things originally was only about 30 feet, about 10 meters as far as accuracy. Now, they are, I mean, just unbelievably accurate, about a meter as far as the accuracy on the regular GPS system. And all of our mobile appliances, mobile phone, your tablets, your phablets, even some laptop computer systems, smart watches, things like that, they all now contain some type of locating circuitry, GPS. And it's also used by internal systems called IPS, indoor positioning systems. And they're accurate down to about a meter, just unbelievably so. But many of those also utilize, in addition to satellite triangulation and the additional satellite for doing that, they're also using land-based systems, um, cellular type of IP towers for doing that type of location. Well, very, very accurate. So the somewhere you are now is also a factor. Basically paint a predefined geofence area, and it's like, okay, as long as you are within this geofence with your user ID and password, you get to log in. Even with a valid user ID and password, if you're not within that predefined geofence, you don't get to log in. Okay. Biometrics is one thing I was mentioning earlier, that you want to make certain that the authentication factor does not cause any undue delay. And there's some issues with initially setting up biometrics, and that you have to scan everybody. If it's facial recognition, or if it's a thumbprint, palm print, retinal scan, iris scan, voice analysis, whatever it might happen to be, you have to send everybody through an initial scanning biometric capture process. And then, especially with like fingerprint readers, palm print readers, things like that, they have to be constantly cleaned, because just the oils that we have naturally on our bodies, some of them are the pH on some of the people's oils is so high that it will literally etch a fingerprint into a glass surface. So they have to be constantly cleaned and maintained, or you get false positives and false negatives. False positives meaning that it will not identify somebody when that's truly is their fingerprint, or false negative when it identifies someone as someone else. So keeping the systems clean there is a utmost important. But these things are accurate. I mean, accurate to the nth degree as far as readers. And I'll tell you, especially now, some of the facial recognition software that I've seen lately is just unbelievable. Young man that used to work for one of my companies now works as a salesperson in a facial recognition software here locally. And he was telling me, he's going, Mr. Donnie, these things are unbelievable. He said, they have progressed so far now. He said, I could take a digital shot of your face right now, and we could compare it to a 40-year-old image, and it would still identify you. Thinking, I don't know now. I said, I've seen 40-year-old images, and I've seen this face, and they don't look like the same face to me. But then he explained to me the different points on the cranium and the face that it actually uses to identify. So I mean, I understand the technology much better now. But yeah, some pretty interesting advances in lots of those technologies. But you have to train them. You have to tune those things in to the populace of your environment before they. And again, you have to fine tune and tune out the false negatives, false positive thing, and tamp it down to where it gets a pretty good consistent hit on the individuals. Here's your ownership, your token. Smart card readers, the fob, the key fobs, sending the HMAC passwords, they call it, hash mandatory access control, or one-time passwords. And a lot of it uses push technologies to email or to a text message, things like that. So regardless of the type of secondary or tertiary factor that you're using, it's a good idea to require multi-factor authentication. I gave you guys the example, I think, yesterday, or maybe not. I always give it in the other classes. But using like a SIM system, security information event management system, where it can capture events from multiple sensor type of programs. Having a person prove that they are indeed who they claim to be with multiple factors, somebody logging in with a user ID and password and then using a swipe card or requiring a fingerprint, all in the same location. That's where you actually identify and give that person the ability to prove that they are indeed who they claim to be. Those push notifications I was talking about use these guys, the text messaging, an alternate email account, even voice over IP functionality, to give that feedback and to give the person that secondary or tertiary opportunity to prove they are who they are. Now we have to understand that those out of band type of push notifications do stand the possibility of being intercepted. I know when I'm doing like one-time passwords, I have an online book account that I purchase books from, and they'll log into the site and they'll send me a token to my web or to my mobile phone. And again, it's time sensitive. Well, I have to accept that token in my authenticator app to prove that it truly me. Now, if somebody had stolen my phone, or if they're sitting aside and intercept that transmission to my phone, well, then that's a possibility that they could validate that system as well. And I tell you, that's another thing that we've seen as far as people trying to attack is, pay requests, for instance, online, on online banking or money exchange apps. So and so has requested this money. Click here to see the transaction. And when you click, you just said, yeah, go ahead and pay them that $500, whatever. So, you got to be very, very cautious and know about those, how those things actually work. Now, we are seeing lots of implementations of this passwordless authentication now, okay? Where we're using like these authenticator apps. Don't have to put in passwords anymore. I have a situation like that, I guess, on my iPad, and it uses fingerprint. And if I want to log into certain websites or if I want to purchase product, rather than me having to key in passwords or PIN codes, I just tap the old finger on the fingerprint reader there, and that's the authentication in essence. So a little bit different way of doing those kinds of things, and they're implementing those in different methods as well. Okay? So that's the first part of that, the identification and authentication factor there. More and more organizations, as I said, now are beginning to require multi-factor authentication, and I think it's probably a good idea because of the fact, like I said, that the social engineers are so very clever, and especially as it relates to talking people out of their passwords and their PIN codes and getting people to offer up information, like I say, that they normally wouldn't divulge, and acting in ways they normally wouldn't act in. So, and the social engineers are just getting better and better and better. So tightening up on the password authentication and the systems authentication in general is a good idea. Now, this is another of the labs I was telling you guys about. If you've never set up password security in a particular network environment, this would actually benefit more from a networking perspective than I think it does for security. But if you've never done it before, it's an interesting exercise to go through. Okay. Now, I talked yesterday about the AAA compliance, the authentication, the authorization, and then the accounting functionality. That is the purview of your directory services, your LDAP, Lightweight Directory Access Protocol services. And of course, in the Windows environment, we manage that through ADS, Active Directory Services. So the access management there is where we start looking into our directory, and then based upon how the system in general is providing access management, well, that's how the access and permissions then are assigned to an individual subject or user when they have validated with their credentials and basically gotten in the front door. Now, there's four basic types, five, but four basic types of access control that these are deployments that network engineers typically will set up. And it's sometimes it's done in cooperation and coordination with the security administrator. Sometimes it's just the security admin is told, here's the way we're going to do it, so all according to your particular enterprise and methodology. One of these is a user managed function, doesn't have any centralized network or domain level management or control, and the other three do. The first one here, discretionary access control, DAC. It is based upon whoever the owner of the object happens to be, or the resource, whatever the resource might happen to be. A file, a folder, a directory, a database, an application, a system, doesn't matter. Whoever is the official owner or creator of that particular object, they decide in their discretion alone what access and permissions are going to be assigned to all the other users. Individual user profiles, group profiles, or the networking universe as we know it. So, but again, it's they have the discretion on assigning those access and permissions. It's not something that's managed at a domain level or anything. It's the individual user or owner that decides what the access and permissions are going to be. Okay. Now, if indeed someone compromises that particular user's profile, then they can assign pretty much any access and privileges they wish because they are flying under the radar and under the guise of being this particular user. So that's a vulnerability that individual object owners' access and permissions to the network in general have to be guarded highly. Then we have what's oftentimes referred to as military level access, mandatory access control. Now, it is indeed a centralized, oftentimes a domain level setup and deployment model. It's where you attach basically security labels to an object. So I say, well, this particular file or this directory, this is the security level that we assign to that. And then any users or groups that want to have that level of access, well, their security profile must have that at least that clearance level or above. So, and then, like I said, is centrally managed, oftentimes by a directory or systems administrator, and they manage that access for all objects, and any users have to have that level of clearance, a security clearance assigned to them, so that they have the proper access to any and all of the objects. And the objects have that security label or meta text, if you will, assigned to that. The other two that we have, two major ones, are role-based and attribute-based. Role-based is where, and again, these are also centrally managed by some type of security manager, oftentimes at a domain level, by the way. Role-based access control, the access and permissions that are assigned to a user group typically for all system objects are based on the role that they play. And oftentimes that's set up as far as a departmental or a divisional level role. Other times it's just based on job role, whatever job role that the user plays. And in some systems or some methodologies here, the network engineers and security practitioners will set up what are called security groups, and we see that as actually a lot in the cloud-based services. Microsoft Azure gives us the ability, well, all the cloud services gives us the ability of assigning these security groups, and then assigning and mapping those security groups to a particular job function or even to a particular department or division. So all of those security groups, access and permissions apply to this particular user group and vice versa. Okay? So that is your role-based type of access control model. That's a RBAC is the acronym there, by the way. And then we have this last one, which is sort of a combination of the attributes and properties that are assigned to both the subject and the object. Gets sort of into kind of if then else kind of control. This is there's a different version of this. It's called rule based, but it's conceptually the same thing. It is usually a combination of a mandatory access control and role based access control that dictates permissions and access that is assigned to a particular group of people. But the definition may even based upon that particular group of people, but it stretches outside of that as well. Let's say, for instance, if I'm in HR and I need to use a particular system network printer to print off certain types of reports, okay? Those reports may contain, pretty highly secure information, payroll information, deduction information, personally identifiable information, things like that. Well, first, the attribute-based control might set up a rule that looks something like, well, you can use this printer, but only during these times of the day on Tuesdays and Thursdays, and only if you belong to this particular department, and at printer report release time, you have to use a swipe card to release it from the physical device, the printer I'm talking about. So you have to be at that device. So that if then else kind of attribute-based control, it looks at both attributes and properties of the object, in this case, the printed report and the printer itself, and the subject that it is associated with, and the user that's actually releasing the printed report. So lots of different attributes or rules that apply there, both from the subject and the object side of the house before before you get the right to actually print the report, that kind of thing. So pretty sophisticated there from a rules base if you look at it. So it's more attributes and properties of everybody, okay? The subject and the objects that dictate how that's going to happen. This is sort of the combination of the same thing. It's the combination of the mandatory access control, the rule-based access control, and the attribute-based access control combined. Okay, not discretionary at all. It's system-wide, and it incorporates some of the rules and filters in all three of those others. I've often heard the attribute-based access control or rule-based access control defined as the same thing. They're not. They're very similar, but they're not identical there. And then there are certain things that we set up, and this is usually a function of setting up the overall system in what's called UAC, user access or user account control. You have encountered this, I would bet $1 to a donut. You go to install an application on a system, and you're not the system's administrator, but this install or this change or this update to an application requires, at the very least, temporary administrative privileges. So you get this UAC panel that pops up, and it tells you this process wants to make changes to your system. Do you wish to allow that? And, in order to install the updates or the patches or whatever, you say, yeah, sure, go ahead and allow that. And it does a couple of things. It temporarily elevates some of your privileges up to where you are a pseudo administrator. You're not the full administrator, but it gives you those temporary privileges. And it also logs this information as a security event in your system log. Okay. It's very similar, not exactly, but very similar to the run as administrator function in the Windows environment, which is where you have to know the administrator's profile. In this case, you typically don't, but it's because the system has been previously configured to allow these temporary privileges, but to log it as a security incident. In the Linux and Unix environment, there's a command sudo, S-U-D-O, that provides that same sort of temporary administrative privileges in order to do those types of things there. Now, I mentioned, I think yesterday in passing, and if you will consider this as a base level starting point, then you are just about assured to have a foundation that is secure by nature. And then you can build upon that with stacking other security apparatus on top of it. But the foundational concept here is called the principle of least privilege. Principle of least privilege um, states very simply that a user should only have the minimum level of access and permissions required to perform the job function. Anything over and above that is a violation of that principle. If you will use that principle in all of your implementations, including user implementations, password implementations, security setups for all of your system objects and resources, your directory services, everything. If you will use that as a foundational component, yet that is the beginnings of setting up a very, very secure environment, or at least an environment where you can put multiple layers of security stacks on top of it. Okay. The issue that we found, and me personally, if I would set up networks, I would always try to set up my access and permissions from a departmental or divisional level. I would create a department or a division object and say, well, here's the permissions and access for anybody in that group to all of these objects on the system, including the network itself. And then anyone that, new employees that were attached to those departments or division, they would assume or inherit those permissions and access. Now, every time I ever did that, I would have one and sometimes multiple users that their specific job function required that they color outside the lines a little bit of those primary group permissions and access. So if it were just one person, I would just manage them individually, not the group as a whole, because you want to avoid what's called permission creep. If you start giving one user and there happen to be in a group and you give the whole group additional permissions to accommodate one user, well, everybody now has those permissions. You don't want to have that. If it were a couple of users in the same department or division and they needed the same additional authentications, well, then I would peel them off, set up their own group, and manage them individually as a new group, so as not to have that permissions and authorization creep that affected the entire group. So have to make certain that I control that, have to make certain that I set up the proper auditing and reporting type of functions on all of that. When I start looking at setting up permissions for individual user accounts, I have to look and see, and again, I always did it from a departmental or a divisional level, what access, what base level permissions and access do the individual users require to perform their job function. Okay. How do those permissions actually relate to the management policies, procedures, guiding documentation? And if everything fits there, then I set up and assign those permissions accordingly. But then I have to think about as well, what am I going to do? What type of multi-factor authentication nowadays, that's the way I would think, am I going to implement to indeed give the users everything they need to prove that they are indeed who they claim to be and that they should indeed have these access and permissions. Principle of least privilege. So I've got to do some pretty in-depth investigation on all of the identities and all of the job functions for all of those identities before I start, provisioning the access and permission to an individual user. And just as important as provisioning is deprovisioning. Give you an example there. I worked with a company out west. They were, I think there was actually two different companies. I think one of them is still in business. I don't know. I haven't talked with them in a while. But I was actually hired on as a consultant to begin with, and then as a full-time employee to build them and manage their learning management system. I immediately realized when I went to work for the company, and I was a remote employee too. I immediately realized that the learning division and the IT division did not get along. There was some head knocking going on there from day one. The learning manager, and rightly so, I agreed with them. They really didn't trust the IT folks to properly manage the learning management systems servers. So we set up our own LMS server outside of IT. Well, that made the rift even worse because then they would not allow us to tap into the APIs that would be necessary for me to validate users in the LMS by way of the directory system that was already resident on the corporate server. So I was going, okay, well, I'm going to have that, at least the employee number, first name, last name, department, basic identifying information, so that all the employees would be able to log into the LMS system. So after some hemming and hawing, and he begrudgingly gave me an Excel spreadsheet that allowed me to load that information into my training database. Well, we nailed him because he had in his database still active, he had in it was close to a dozen employee profiles of people that were still active in that database. And I'm talking about active to the point that they would still be able to use those credentials to log into their point of sale systems in their brick and mortar stores. The profiles were still active, and a couple of these folks were employees who had been fired and marched out of the building 2 years prior to this, and they were all still active in the employee database. So we went through and I weeded out all that stuff, and I gave that information to my supervisor, who just championed that thing. And of course, I mean, the squabble was between them, not me, but he used it as a pummeling piece for the CIO guy there, and rightly so. I mean, that's unacceptable. You got to make certain that you deprovision. Now, you don't delete all of that data, but you deprovision their permissions, you deactivate their access. And I'm talking about employees, contractors, business partners, any and every one that has had a user profile provisioned and gained access to system resources. You got to take those away. Again, you don't want to delete this stuff because you may need to do some reporting on it after the fact. But most certainly don't have the credentials still active so they can log into the POS system in the brick and mortar store. So provisioning, deprovisioning, very, very important. Now, in the Windows environment, and we've had this for a long, long time in other operating system environments, Unix, Linux. In the Windows environment, and this is, I guess, in the scheme of things, relatively new, we have this, it's an application or an applet, a management applet called the GPO editor, a group policy object editor. It allows me to set up things such as access and permissions at individual user level. It allows me to do things such as evaluate users when they log into the system. And I can even take it further than that. I can create the whole password policies and enforce password rules, access and permission rights, things like that. But I also can attach this thing basically to a login scripting program. So I can evaluate a user and their system when they log into the network. So I talked yesterday about, people rooting or jailbreaking the mobile phone or the personally owned devices. So if they go to log into my network with one of those devices, I can use this type of system, look into that device. And if it falls outside of what I consider to be compliant, well, hey, they don't get to log in. If they've rooted or jailbroken a portable device, nope, don't get to log into my network. If they have unauthorized software or an unauthorized configuration, nope, don't get to log into my network. And I can control lots of that with this group policy object editor. And it's an applet program, management applet program that comes typically as part of the operating system that allows me that window, as it were, into those individual systems. And I can use it to enforce, corporate level policies and procedures on those individual systems. Another thing I can do there, and I actually implemented this in and another company I worked with, login time restraint, time restraint policies and procedures. Worked with a company. It was a call center company, and we ran 24-hour, well, 22-hour a day shop. We had 2 hours that we did end of day wrap up, and we would have users that eager beaver users that would want to get in and log in 30 minutes early so they get 30 minutes overtime. But they were trying to log in the wee hours of the morning into their session while we were still doing end of day wrap up from the previous day. So we set up these time-based, procedures or restrictions that said, nope, you don't get to log in until 6 a.m. period, not 5:59, 6 a.m. So then we would turn on the login functionality and only allow them that login at that time. We only had 2 hours every night to do the end of day wrap up. So from 4 to 6 a.m., systems were down, with no telephone calls were taken, and we did our end of day processing for the previous day. And you can also do that same thing for location based stuff. That's some of that geofencing I was talking about, but you can also limit it based on location specific IP addresses, things like that. Okay. The policies and procedures and controls that I set up that limit access or control access to a particular environment is very, very important. I want to make certain that I have in any network environment, I have the proper controls that allow me the reach out and touch it control, especially remote systems, mobile systems. I want to limit things such as accounts that have administrative privileges logged in all the time, every day on my network. Believe it or not, systems administrators, for the most part, only probably somewhere in the neighborhood of 25 to 30% of the functions they perform each and every day is when they truly need that full administrative privilege. Otherwise, and this is a personal preference, I would prefer they operate under a profile that has less privileges, still considerably above the standard user, but not the full bore, all no holds barred, godlike access that the full system administration would give those users. It's way too easy to shoot yourself in the foot, and I speak from experience. If you have that full administrative privilege 24 hours a day, okay, there is the run as administrator functionality in Windows, the super user do functionality in the Linux or Unix type of environments. So I would limit that privileged access to only when it is needed. And it goes back to that principle of least privilege. Users should only have the minimum level of access and permissions required to do their job. Anything beyond that is a violation of that privilege. So we have to always think about that. So that's your IAM functionality, the identity access management functionality there. Okay. Now, identity management in general is sort of an extension of that. There are several different methods that have been put in place now for that on local systems and on remote managed systems, things like that. Let's see what we have here. Teal has, from a cloud-based RBAC perspective, does the exclusive deny rule apply? Example, there is a user assigned to, boy, I'm having a hard time reading that text, to two groups. One group gives access to the file folder, but the second group has a deny access to the file folder. Is the user denied access to the file in the cloud? According to how the cloud permissions, Teal, are set up, I want you to understand, in the cloud-based environment, regardless of the subscription that you have, I mean, there's the three majors: Microsoft Azure, Google Cloud, Amazon Web Services. All of those contain active or directory services based in there as well. So it's all according to how they're set up and what user or what group that user is actually assigned to. If they log into a cloud virtual computer, they will get an assignment to a profile there. If they log into a local system, they'll get an assignment to a profile there. So it's all according to how it's set up and how it's managed, as a matter of fact. I can set up Active Directory services on my Windows domain controller in my local environment, but I can have it real-time piped into my Microsoft Azure Active Directory services in the cloud environment, and I can manage either or from either or location. So it's all according to the profile that that user is currently attached to when they log into one or the other. Good question, though. Really good question. And again, it is you are very welcome. I appreciate it. It's all according to where you're doing the management from, and as I said, what profile or account the user is logged into at either or location. I want you to always remember, just because you're logged into a virtual computer in the cloud, it's still a fully functional computer with all the same requirements and rules that you would have in a locally logged in network host as well. Now, remote authentication, same as local authentication. You're going through some type of directory services to do that IAM functionality, identity access management functionality. Now, there are these services and servers that are referred to as AAA compliant services. And of course, those three A's, like what we talked about yesterday, the authentication, authorization, and accounting functions. In a local Windows environment, that service is referred to as Kerberos, Kerberos with a K. Some of the older Windows legacy systems, and I'm talking about prior to Windows 2000, they used a function there called LAN Manager, New Technology LAN Manager, NTLM. Whether you're logging in local or remote, the age of the system has everything to do to the authentication services you're logging into. Now, in a Windows environment, the Kerberos service is referred to as a ticket granting ticketing system. You basically log into the Kerberos, the Key Distribution Center, they call it KDC, and then you present your validation credentials, user ID, password, and they can, of course, require multi-factor authentication as well. So when you first log in and get validated, in essence, it punches your ticket through the front door. Okay, that's your initial entry into a Windows domain network by way of the key distribution center that Kerberos provides. Now, the default setup on the Kerberos servers is that if you then want to access any of the other systems, the tertiary systems, email system, learning management system, content system, database, whatever, the default is you'll have to return back to the KDC, present your previously identified credentials, and in essence, get your ticket punched for those other subsystems. Now, sometimes they can set it up to where it may require additional credentials. I've seen that in the bits, as a matter of fact. You log in, if you're logging into an on-base DoD system, you put your CAC in the slot in the laptop or the terminal itself. You get validated into the network, but then if you want to go check your email, you may even have to present additional credentials for the email. But anyway, any of the systems that you want to gain access to, you represent to the KDC and in essence get your ticket punch for the tertiary subsystems as well. Doesn't have to be set up that way. Kerberos and most other login systems have the ability for doing what they refer to as a single sign-on. Once you validate the one time, you basically get your ticket punched, or a golden ticket, it's called sometimes, for every subsystem inside the network without having to represent every time. Okay. In the Linux and the Unix environment, they utilize a little bit different concept there. There are they call them PAMs, pluggable authentication modules, that sort of offload the functionality and the access and authentication to other subsystems. And there's actually two different files that are utilized in a Linux Unix environment Both of those live in a directory called etc. There's the password file, which is the clear text password, and then the shadow file, which is the hashed copy of those passwords. And anytime somebody logs into that system, it revalidates that hash against the clear text password and against the stored hash to make sure that it's the proper user there before it allows you to get through. So a little bit different concept there on those systems. All of them utilize this LDAP protocol, lightweight directory access protocol. The rules that actually guide the way that database is set up and the attributes and property information there is called X.500 LDAP. Can somebody tell me right quick, and this may be a question you get here, what is the default communication port that LDAP uses in computer system? Oh boy. Every one of you should know this. Everybody should know that. Okay. Yes, Jorge, that is correct, but I'm the dude asking the questions around here. Yes. Port 389. Very good, sir. Yeah. Now that's the non-secure port. There is a secure port for LDAP at 686. But yeah, you guys got to know those communication ports now, the protocols that go along with those. Because they every now and then they'll throw a zinger question at you, even in Security Plus, that just assumes that you know a particular communication port, especially all your common ports, by the way. Now, inside of the LDAP database, they have information in there that tracks attributes and properties for each individual LDAP record. And inside the LDAP database, they track both the subjects as well as the objects. The subjects are individual users, group profiles, service profiles, and the objects are everything else, the network, the files, folders, directories, printers, database, everything that one might need access to, including host machines, server machines, and so on. Inside the LDAP database, they have these attribute value pairs. And there's one, the primary one that we have that is, it's more documentation, anything called a common name, CN. And then you have an object unit identifier. You have the object itself. You have country code sometimes. You have individual domain controller specific attributes there. And it's a whole list of attribute value pairs that further define all of the subjects and objects inside the system that are being accommodated inside the entire system there. Okay. So that's your directory, Active Directory services in Windows and in the cloud-based environment. And then in all the other operating systems, they just refer to the LDAP database. Here's the concept I was talking about with Kerberos. You present initially from your host machine. You are the principal user to the KDC, the Key Distribution Center. It validates your credentials, user ID, password, and it can be set up to require multi-factor authentication. When the KDC, in essence, punches your ticket, you've made it to the front door. It then encapsulates that credential information, and conceptually, it can be viewed as the same sort of thing as a cookie. It's a little validated key file that it throws back and stores on your client machine. And then any of the other subsystems that you want to gain access to, you have to present your punched ticket to those subsystems. Then it may go back to the KDC to say, well, does this user have access to this subsystem? Application server, database server, web server, content management system, doesn't matter. Okay. And then you basically get your ticket punched for that subsystem or that function there. If indeed you have the golden ticket where they do the single sign-on, where you don't have to make that round trip all the time to the KDC, you just present your ticket to whatever subsystem it is you wish to gain access to, and you have that access with a single sign-on kind of functionality. Okay? So either you go by way of the KDC or you go directly to the other subsystem there. Now, there's a concept, and we see it quite a bit, as a matter of fact, out over the World Wide Web now. It's called ID federation or federated sign-on, federated services. And I know you guys have encountered it. Lots of websites you go to, you get the login screen and it says, well, use your credentials to log into this website, or you can use your LinkedIn credentials, or you can use your Gmail credentials, that kind of thing. Those are what are referred to as IDPs, identity providers. Those identity providers will accept and validate federated other systems and users, oftentimes competitors, which I find interesting. And they'll just accept their validated credentials. So I can log in with my LinkedIn credentials or my Gmail credentials, or I've seen some of them even using like Facebook and TikTok, those kind of things. They will cross boundaries there. Now that to me is a little bit scary, and I'll tell you why. We have never ever in IT history seen that accommodation across the boundaries, especially among oftentimes competitors. Okay, makes me wonder if maybe old Skynet is not truly right around the corner. So a little bit scary there, but they use these markup languages here. This one's called SAML, and it's a derivative of XML, as a matter of fact. And it's a tag-based language, much like XML or HTML or some of the other markup languages that actually encapsulate and move these data around over the public internet. Or sometimes we see it moved inside of an autonomous network with another protocol called SOAP, Simple Object Access Protocol. And then there's there's one called Java Web Tokens, but it encapsulates this stuff in a pretty secure environment and sends it, for the most part, if it's out over the public internet, it uses the HTTPS protocol, port 443, Hypertext Transport Protocol Secure, and then it wraps it up inside markup language, security assertion markup language, or SAML. And like I say, it's a direct derivative of XML, the extensible markup language. Okay? Uses digital signatures, signed, encapsulated, encrypted data strings that flow across network connection. This guy here is one that we see a lot in some of your, I call them the social engineering sites, social networking sites like Facebook or TikTok or Pinterest or X, and some of those. A little bit different concept, and it's because it moves a lot of these interactions in and among the same networks. And it's same concept as the the single sign-on ID federation thing. It's called open ID and open authentication. These are the ones that use the JSON objects, the JavaScript object notation, and Java Web Tokens to move this data around the World Wide Web in very secure format as well. Okay, so you have your identity providers, and then the individual websites that all share this information. Again, for me, a little bit scary because in many cases they're competitors. They utilize these the federated services utilize predefined application programming interfaces, as well as predefined protocols that send and receive the data, as well as send and receive successful or unsuccessful status information. One of those is RESTful. The representational state transfer is an API that basically sends and receives updated status information. This was a successful transfer. This was a failed transfer. Resend this, that kind of thing. So whatever version of this they use, whether it is the XML, the SOAP, JSON, the Java Web Tokens, whatever, it's very secure information that is exchanged between these identity providers, and they're all, like I say, accepting one another's credentials to allow that cross the board compatibility. Again, sometimes among competitors, a little bit scary. Okay? So that's identity and access management in a nutshell.